pi is about 3. So, yeah, so you know the joke. The engineer's pi is 3, right? Physicist's pi is 3.1416. And mathematicians is like, yeah, you have to have pi. Nothing else works. Okay. So anyways, 4 over 3 times 3, that's 4 ninths, so 0.4 something. So you can see that the center of mass of the circle is slightly less than half. That's what you get. Right? But then, in this question, when you're looking for center of mass of a sphere, let me clarify the words first. What's the difference between center of mass and centroid? Well, centroid is a special case of center of mass when the density is uniform, okay? That's what it means, okay? So centroid means that the density is a uniform thing. If you have a uniform density, the center of mass is not going to change whether you make it denser or lighter, okay? All right, so this one, you might think this is the same thing as that one, but it's different because imagine this. You take this shape and you flatten one dimension to get this thing, okay? Right. Now, what do you see? If you do that, then you see that things down here, you zap the bigger circle down, right? Then top, right? So you end up with a two-dimensional object. If we say the mass is conserved, we're going to end up with a two-dimensional object which is not uniform density, but rather you have higher density down here than at the edges, right? And also, overall, the average density down here will be much bigger than the average density on the top, if you think about zapping it, okay? Which means that the resulting center of mass should be less than this one, okay? So I would say the answer should be less than 0.4. Okay? So let's see if this is actually true. Yes?
Is it just the derivative of, or no, I'm sorry, the integral of 4 over 3 pi a, so it would be like 4 over 6 pi a squared?
Well, that's definitely not the answer because, yeah. Well, I mean, here's the reasoning. See, this is height A, right?
Yeah.
Yeah. So if you have A squared,
Yeah.
then A squared will have the unit of length squared. And therefore, the unit doesn't match.
Yeah. Okay.
Yeah, so in some cases, you can just look at the dimensions and right away see something's wrong. Okay.
All right.
Yeah. I didn't want to shoot you down just like that, but I meant to find a quick way to see if something works or not. Okay. Yeah.
Okay.
Yeah. All right. Our idea of center of mass is that it's the average value of, see, right now, the center of mass will be right at the center because of symmetry. Only the z coordinate will be non-zero. X and y will be 0. So what we're really looking for is the average value of z, average over every point on the sphere. That's what we're getting. Okay. So you have over this sphere. So this is my poor drawing of a half sphere, okay? We're integrating z dv. So we're adding up all the z coordinates, okay? And then we're dividing it by the volume of this thing. Now, last time we proved that the volume of the sphere is 4/3 pi r cubed. And this one, because of this one, the radius is 1. And because this is a full sphere, our volume will be half of this guy with r equals to 1, which just gives you 2 pi over 3. So that's going to be the thing that we will divide later, okay? So for now, all we are going to do is just focus on calculating the top integral, okay? All right, so let's do this. The top integral, to cover this area by the spherical coordinate system using the rho and phi and all that. First of all, rho goes from 0 to where? It's a sphere of radius 1, so it goes from 0 to 1. Remember, dv in spherical coordinate system is rho squared sine phi, d theta d phi. Okay, what about theta? Theta is?
0 to 2 pi.
Yeah, goes all around, right? So 0 to 2 pi. Okay, now what about phi? Phi comes down from the North Pole.
0 to pi over 2.
Yeah, because you end up with the equator, so you stop at pi over 2. Yes?
Is it supposed to be a d rho?
Oh, thank you. I forgot d rho. D rho, d theta, d. Yeah, for 0, 1.
So
Okay. So we can't integrate this yet because why? What's the problem? Huh?
Z.
Z. Yeah, Z is not in terms of rho, theta, phi. So remember this picture. Z, R, rho, and then phi. Yeah. There are two reasons why I keep drawing this picture. One is so that you can remember this picture instead of memorizing stuff. And the second reason is that I actually don't know the formula. I always have to use this to figure it out. Okay? Yeah. So that's how things work. Yeah. You might be surprised if you knew how little I know about math and just have it memorized. How little I have math memorized. Most of it is like derivation on the spot. Okay. All right. So you have, well, not this one. I would definitely memorize this, but this I have to figure it out. Okay. All right. So what is Z? Z is rho cosine phi, right? Okay. Good. So I'm going to put that in there. And the result is that we need to calculate the integral 0 to pi over 2, 0 to 2 pi, 0 to 1, rho times rho squared, so it's rho cubed. And there's a cosine phi and a sine phi, d rho, d theta, d phi. Okay? Rho cubed integrates to 1/4 rho to the 4th, cosine phi, sine phi, and you have to plug in 1 and 0. 0 to 2 pi, d theta, d phi, 0 to pi over 2. And when you plug in 1, you get a 1/4. Now, let me skip the part where you integrate by d theta because that's kind of easy. If you integrate, there's no theta here, so theta pops up. And then you plug in 2 pi, you get 2 pi. You plug in 0, nothing happens. So you end up just getting a factor of 2 pi. Okay. Does that make sense?
Mm-hmm.
Yeah, it's not that hard. So it's easy to see that 2 pi is what you're going to get after you integrate by d theta. So what's left is 0 to pi over 2 of cosine phi, sine phi, d phi. Okay. Question, how do you integrate that? U sub, okay. That's very easy. So you need a U substitution with U equal to, let's say, sine phi. Okay, in that case, what is du equal to?
Cosine.
Cosine phi times d phi, right? So this much, cosine phi times d phi is going to be u, and this one right here will be u. So you just have integration of u du. Okay, so let's write that down. 2 pi over 4 Um, oh, but you can't end there. You also have to figure out what happens to the value of u when phi is 0 and pi. So what is sine of 0?
0.
0. So this gets replaced by 0. But u is sine of phi. So when you have sine of pi over 2, what's the value of u? 1. Sine of pi over 2 is 1, right? So that gives you 1. Okay. And then you have u du. I needed to change these values. Don't forget to do that. These are the values of u. Since I have du, you have to put the values of u here. Okay. You can't just stay with 0 and pi over 2. Make sure you change that. Then that integral is 2 pi over 4 times 1/2 u squared with 1 and 0 plugged in. You can see that 2 and 1/2 cancels out. And you get pi over 4 times 1. Okay, that's what you get. Okay. All right. So, is that the answer? Is that the centroid?
No.
Why not?
That's the average z value.
No. This is the numerator.
Divide.
It's divide by this. Okay, so you see the average z value is pi over 4 divided by 2 pi over 3. And remember, dividing by a fraction is same as multiplying by its reciprocal. So you put you flip this upside down and you put it right here. And you can see that pi and pi cancels. And you get 3 over 4 times 2, which is 8. Now, in terms of decimals, this is 0.375. So indeed, it's less than 0.4, right? So just as our intuition said, that this is what you get. Oh, by the way, this is radius 1 half sphere. So what that means is that if you have a generic radius A sphere, then the center of mass will be located at 3/8 of A. Okay. Is anyone taking statics right now? Okay, yeah. So take your statics textbook, either the PDF or whatever, go to the end and look at the appendix, and you're going to see the centroids for various shapes. And this is exactly what you'll see, okay? And for the disk, that's what we had. Just one more comment. You're also going to see something like the right tetrahedron. So you have rectangular tetrahedron. So it's like if you're on the first octant and you cut it by some plane that's passing through the XYZ plane, the XYZ axis, right? And let's say if this is A and then B and then C. So if this is like this C and that's like this A and so on and so on. What's happening is that Y bar is the average of the Y value, right? So the actual center of mass is somewhere in the middle of this tetrahedron, right? And you get that by, because this is linear shaped, you can kind of make an argument there, but you have, this point is, what's this coordinate? This is 0, 0, C. This point here is 0, B, 0. This point here is A, 0, 0. And then over here is 0, 0, 0. So the average of the Y value is just simply add up all the Y values, which is 0 plus 0 plus 0 plus B. This is the only non-zero Y value, right? And you divide it by 4. So you're really taking the average, and because it somehow like connects all these points and fills in all the midpoints, this is what you get out of the centroid. So Y bar will be B over 4, and then X bar will be A over 4, and then Z bar will be C over 4 because of exactly this. Okay, so you could also do some similar integrals. This time you can't use spherical, you have to use rectangular. and get the same result, or you can just use your intuition that this is what you're. Okay? So having this kind of experience really strengthens your understanding of what's going on behind these statistics. Not statistics, statics, engineering statics.